My name is Zoltan, and this is the WindHopper, an airborne wind turbine that I have been developing with my friend Bernhard for quite some time. It's still early stages, but I wanted to show you now. There are quite a lot of companies who have tried or are trying to bring airborne wind turbines to market. So, for instance, just in Germany, there is SkySails Power in Hamburg, there is Kite in Berlin, and there is Quadcopter in Munich, which all have slightly different designs of airborne wind turbines. So the major incentive to develop an airborne wind turbine is that if you have something like a kite, you can reach very high altitudes with very little material and costs. And the wind power is significantly stronger in high altitudes. So for instance, for this small scale WindHopper that we see here with around 2 meter diameter rotors, if you have 50 meters flying height or altitude compared to the ground level, you have 3 times more wind power because you don't have obstructions of trees and buildings, and the actual power that you can harvest goes with a cube of the wind speed. So if you double the wind speed, you have 8 times the wind power that you can harvest. But of course, having a flying wind turbine is also much more complex than having a normal tower and a normal turbine. And up to today, there's no airborne wind turbine that has actually reached the market. And so for the design of the WindHopper, we looked at a relatively simple design idea where basically we have 2 rotors counter-rotating that are in autorotation, which means that when they are flying in the air, the wind will make the rotors rotate, and that will then provide lift to lift the whole kite in the air and keep it in the air. So it's basically an autogyro kite, which is basically autogyros are more or less like the predecessors of helicopters. So they have been around quite some time, but they have not been used, at least in the product on the market, for airborne wind turbines. So there have been some companies trying it some time ago, but not anything that you can buy. And so the idea is that you have motors mounted and through a gear, approximately 1:7 or 1:10 gear ratio, and that when you want to start the kite, they can assist by basically accelerating the rotor, similar to a helicopter or a drone, because often you have already sufficient winds in higher altitudes, but because of the trees and the buildings, you have insufficient wind speed at the ground level to even get the kite starting. And therefore, with this design, the idea is that you initially can use the motors to get it off the ground, and then once it's flying, the wind actually will accelerate the rotors, and then with the motors they will be used as a generator to produce electricity and transfer the electricity through cables to the ground station and the battery in this case. The main design idea behind the WindHopper is that it should hopefully be passively stable, where if you design it properly, you don't need significantly active control of the kite, but that it should be aerodynamically stable just from the design of it. And if we are successful with it, this should be much easier to develop than a system that needs real-time, very fast responses to aerodynamic forces. And so this should hopefully have a shorter relatively easy, but of course still complex, road to full autonomous launch, static flight and landing. And then dynamic flight, which is typically done in a figure of 8 with these airborne wind turbines. It can be developed later, and then again, because the power that you can harness goes with the cube of the wind speed, and when you go crosswind, you increase the effective wind speed that the kite sees. You can get an up to 10 times power increase by flying this figure 8, which is more complex, but can be added later to the design. Yeah, so the principal idea or design we got from Rüdiger Kröning, who has a lot of kite designs on YouTube. Yeah, so this is like from 2023, a design which looked still quite similar. So the idea was to have some rods to protect the plates from collisions, and also some people if they're colliding, if there's a crash. And it uses rope drives both to get the gear ratio, but also the idea was to have just one motor in the middle to drive both rotors counter-rotating. The rotor plate design was very simple, just a piece of corrugated plastic. But in the end, the design didn't work out. So both the rope drive wasn't reliable enough, and also the rotor wings were not stiff enough so they would bend too much in the wind, and I wouldn't actually get any auto-rotation of it. So I went back to the drawing board and designed or built rotor plates out of balsa wood with a spruce wood leading edge that I also saw on somebody do in the internet. I will put the link in the description below. So it was quite tedious work. So first you have to glue the spruce wood to the balsa wood, and then you have the profile that you want. So in this case I used Aquila 9.8 as a wing profile, which has a nice feature that is more or less completely flat on the bottom. So you more or less only need to file and sand the top part. And so I basically printed the negative profile with a 3D printer, and then glued some sanding paper on it. And then first with a file did the rough form, and then with hours of sanding had this profile to the wings. I then added some TPU wing tips. So TPU is like an elastic printing material that you can use, and the idea behind this is that in case of collisions, that it protects the wing, so that the complete wing is not destroyed, and it also acts as a wing, a tip weight that improves the outer rotation, because typically the wind is not completely stable. So if you have more weight at the tips of the wing, you have higher inertia. So if there's a decrease in wind speed, you not immediately decrease the rotation speed and lose lift, but instead there's some rotation energy stored that can keep you flying. And then finally I taped it all with some PP packaging tape for weatherproofing and also a better aerodynamic surface. And so here you see the motor mount and the gear 1 to 10, and also a teetering hub. So this is typical for autogearers because you have a different lift on the side where the plate is going against the wind compared to where it's going with the wind, because you have again different effective wind speeds that the rotor plates see. And to prevent a lift asymmetry and also vibrations, you typically have this teetering hub for these autogearers or autogear kites. And so here I did first test of the rectifier that I built. So later on I will power the kite or the motors with a motor controller. But for my initial test, I just wanted to see if I get some electricity out of it. and rectified the 3 phases of the motor to get a DC power. So this is the first trial to see how autorotation works and if I get some power. And so for this test I actually produced, so first you see that autorotation works quite well in contrast to my very first prototype. And also I produced up to 30 watts of power. It's not so much, but I think it could have also produced more. It depended more on the voltage that the motor was outputting and the resistor that I used in a small rice cooker. Yeah, so once I did the autorotation test and it worked, I then finished building the complete kite that you see here and did some flight tests. And so as you see, the rotors are rotating in autorotation quite well with the wind, and they produce sufficient lift to lift the whole kite and cable into the air. But yeah, it's not flying stable.
Gefährlich. I love it.
And the main issue is that very likely the brittle point or the attachment point of the kite string to the kite is at the wrong place. So it should be closer to the trailing edge of the kite, the tail. So here you see it again. So you first, for getting into the auto rotation, you first have to start the rotation by hand, but then it picks up the speed because of the power of the wind. Yeah, so I just show you a short clip here, 1 minute to see to show you how it flew.
Was würdest du sagen, würdest du noch steiler machen oder? Okay. Aber ich glaube, dass es immer noch fortschreiten würde, oder?
Yeah, and so you here see the after one crash, so we had like at least half a dozen crashes of the kite, and so the plates survived quite well, so only had very minor damage. And one reason was the TPU wingtips that I showed you earlier, but the other one was also that the attachment to the teetering hub, I did it with 2 bolts, so one metal and the other plastic, and it was meant to do exactly what you see here, that in the case of crash, the plastic bolt would be destroyed and then let the rotor wing rotate freely around the metal bolt, and then prevent it from cracking during the crash. But the kite frame made out of carbon tubes didn't fare so well, so we had to replace quite a bit, and at the end the complete carbon tubes were destroyed. Yeah, but we're still quite happy, and so this is also like me on the left side and Bernhard, and on the right side is my friend Immo, who also helped out in the day of the testing. And so, like I said, the major point will probably be just to move the attachment point of the kite string, and then hopefully we'll get a stable flight. Yeah, and so while we're still working on the 2-rotor version, We also have the plan to go to a four rotor version. So actually Bernhard is already starting building it. And this is a model that I built, which is basically designed to have very lightweight and large structure to mount the four motors and rotors on it. And then a bit of a crazy idea is that actually if you scale it all up, you could potentially have not only a kite, but also something that you could use as a drone, and which could potentially be powerful enough to carry a person. And because like if you scale rotors up, the larger you get, the less power you need to keep a specific weight flying. So that's why if you look at like human powered helicopters or quadcopters, they are very, very huge. They have like 20-meter diameter of the rotors. So this case is not as extreme, but also significantly larger than your normal drone. So what we plan is that if you have a quadcopter with 4-meter diameter rotors, you have like a total rotor area of 50 square meter. And then you have a person attached with cables, and the person has like a battery backpack with around 20 kilograms of batteries. Then with this setup, you could potentially have a range of 60 to 90 kilometers at a power of around 4 kilowatts at a cruising speed of 60 kilometers per hour. And the nice thing would be that you could fly this 60 to 90 kilometers and then land, attach the cable to a tree trunk, and start the WindHopper as a kite, recharge the battery, and then go on the next hop. So basically the range of a single hop is only this 60 to 90 kilometers, but then you recharge like half an hour or so, and you can go on. So you more or less have unlimited range. So you can do all hops, smaller hops, and go anywhere you want if you have sufficient wind. Potentially you could also use thermals to do the same thing, a bit slower. Yeah, so this is a really nice idea. We were very, very far from it, but yeah, it's a nice idea. We will see if we will be able to make it as light and safe to make this actually a reality. Another nice thing of developing this is that we can break it down into really nice milestones. Right now we have proven the first flight. The next thing would be to get actually a stable flight with only one line. So you saw in the videos we actually needed 4 lines so that the kite wouldn't crash. And then you have basically these milestones with very rough time estimates until we hopefully get one day to the manned flight.